The process at the heart of perceptual control is a very simple feedback control system, but there's probably a lot more going on than people are aware of. So let's take an example, an everyday task of writing the letter F. From a perceptual control point of view, what variables, what perceptions are being controlled? Well, first of all, there's the brightness or thickness of the line itself, which is achieved by varying the pressure applied to the writing surface. If you apply a high pressure, you get a thick line. If you apply low pressure, you get a thinner line. But even that pressure is a controlled perception, as you can feel through your fingers whether it is high or low. And what you're doing is changing your muscle tensions until you perceive the pressure as you want it to be and keep it constant, which in turn keeps the thickness of the line constant. But maintaining a constant pressure and thickness for the whole of the line is a complex task, as it is being done by an arm that has at least 3 degrees of freedom. The shoulder can move in a couple of directions, the elbow can be extended, and the wrist is twisting. All of these joint movements also are perceptions that can be controlled. Now, if the traditional approach was taken of calculating in advance what movements of the joints would be required to maintain a constant pressure, this would mean a computational nightmare. They would also require detailed knowledge of the system parameters such as the length of the limbs and the absolute position of the hand, the pen and the whiteboard. It would also require the system to incorporate complex equations of motion in order to perform the necessary calculations. But the perceptual control approach, on the other hand, doesn't face the computational problem, nor does it require the same knowledge as it's not attempting to compute actions in advance. Instead, it is varying the outputs of many systems in real time in order to control what it is perceiving. So the degrees of freedom problem is resolved by controlling many different perceptions at the same time. So what else is being controlled in this situation? Well, there's the initial position of the hand in relation to the whiteboard so that the whole figure can be drawn. So here rather than here. There's the visual relationship between the stem and the crosspiece. So here rather than here or here. There's the size of the whole figure. And the actual configuration itself, so an F rather than a T. There's the curvature of the upper stroke. And then there's the speed of drawing the whole figure itself. And this last one indicates a higher level perception of the quality of the figure, which varies the lower desired speed in order to achieve a desired quality. So here's a basic example of a hierarchical control where the goal of a lower system is varied to realise the goal of a higher system. But also below the speed control is the arm control system as well, so there are multiple levels involved. Now I can actually draw this figure with my eyes closed, as not all the perceptions being controlled are visual, some are proprioceptive. But then now I'm going to run into trouble because some of the perceptions do require vision. So to draw the crosspiece, I need to control the visual relationship between the stem and the crosspiece. So this is a good example that to control something you need to perceive it. So here for a particular task, we can see that it can be achieved by control of perception, but there are many different perceptions that need to be controlled at the same time, even for something very basic. So in this case, there's line intensity, pressure, arm joints, position, relationships, configuration, size, curvature, speed, quality, and there's probably many more. So rather than needing one very complex system, the task is resolved by a multitude of simple systems, each of which are controlling particular perceptions. Now, conventional robotics doesn't appreciate what is involved in basic behaviour and doesn't take these intricacies into account. What hope is there for such things as self-driving cars?